Good morning again, everyone, and welcome to those of you who have just joined us. I'd like to take this opportunity at the start to thanks for taking part today. My name's Mike. I'm from the Manufacturing Solutions team at Quadra Solutions. Most of you out there will have crossed paths with me in the past, and I'm joined by our application engineers, Matt Hutchinson, and also Chris Smith. The objective today is to raise awareness for iLogic, a feature that most of you already have but don't know it, or know where it is but don't have the faintest idea of how to use it. Our plan today is to demonstrate solutions that are being implemented using iLogic to enable companies to automate their design processes. Right, so I'll start proceedings by quickly explaining how iLogic came to be, what it is and what it aims to deliver at the user level. Then an overview of the business benefits associated with improving the workflow in this way. Now, there are companies out there who are already ahead of the curve on this, and some are running away with iLogic at the moment. We'll take a look at what they might be doing differently, including some analysis from independent research, Tech Clarity, which focuses on design automation. And it also provides some useful stats for the number crunchers out there, drawn from companies already using it. This should lead neatly onto one of our own regional case studies, and then Matt has prepared some demo material out of Inventor, which will then show iLogic in action. Then we'll summarise on how we at Quadra can support an adoption project, finishing off by working through any questions raised throughout any of the above. All in all, we should be finished in about 40 minutes or so, including the Q&A. On that subject, by the way, you should notice the chat feature to the right-hand side of the screen, over here. You can use this at any point for your questions or comments, so that Chris, Matt and I can pick up on them all at the end. So if everybody's happy, we can begin. What is iLogic? iLogic used to be a separate application that could be bolted onto Inventor and was purchased from a company named Logimetrics. Anyone knew of that? For anything up to about $4,000. Autodesk quickly realised its potential within Inventor and brought the product in 2008, embedding it into the Inventor and Inventor Pro in 2010. iLogic is essentially a programming interface that sits at the front end of Inventor and, with the right know-how, is very easy to use. It can be used to drive parts or complex assemblies, and 90% of the time is used at the user level of platform-based or modular-based design. The end result is usually a condition-based set of rules that can drive the model automatically and or manually through a dialog box interface that sits underneath your File Explorer in Inventor. That allows you to quickly manage properties of a sketch by tweaking some variables and clicking Go, basically. So where is it? It's embedded into Inventor and Inventor Pro and is subsequently installed as such, so there's no need to download and install it separately. As I said earlier, iLogic was rolled out from the 2010 release, so if you're using Inventor 2010 or later, you already have it as part of the full product. Note that LT is not mentioned. iLogic doesn't come with any release of Inventor LT. Similarly, if you're using 2009 or previous, you don't have it either. But 2010 users and above, with Inventor and Inventor Pro, you do have it automatically. Its primary objective on this earth is to reduce time spent on repetitive tasks and to reduce human error by building intelligence into existing and new models to drive parameters, properties and component statuses. It automates repetitive tasks, or maybe tasks requiring repeat manual calculations. It can generate rules that update the model based on pre-programmed commands or conditions, like material selection based on volume, or pop-ups maybe if you need to insert a safety feature, if a gantry exceeds a certain height and so on. It can therefore, in that regard, help to maintain conformity to business level standards and practices. I don't know, there's a lot of people out there watching this, so I don't know about all your individual standards, but ISO, HSC, CEs, etc., etc. If you've used external tables or macros to drive linked dimensions in a model, This is one of the basic things that Inventor can do with iLogic, thus bringing the model intelligence back into Inventor and reducing the need to use external programs. You can still use iLogic, by the way, to interact bi-directionally with external spreadsheets if you like. As I said, design time on job and instances of human error reduced, thereby improving right first time accuracy and time to production, in some cases by around 50% and sometimes higher when working with platform design or rules-based engineering designs. So what do I mean by platform-based and rules-based design? For those of you not in the know, concept of platform and modular design are already well established in the manufacturing industries and certainly have a place in industrial machinery. With a bit of strategic planning, distinctive products can be created using similar base platforms, thus significantly lowering the initial development costs and making customization easier thereafter. Also, making a product modular enables easy customization by pre-programming variants in the planning stages. This way, fewer unique options have to be considered, both during production of the initial bid GA or general assembly, or engineered at the time of production. It is important to note at this stage, for the people looking at this, yes, these approaches can extend new product time initially the first time round, because these variants have to be planned and developed and programmed first time around. But that time then gets saved multiple times over by responding to quotes faster and more accurately later on. So if you've got it right first time, you can run it thereafter and save yourself some time at the back end. Rules-based design. This enhances development even further by capturing the knowledge of your engineers and programming rules to configure products alongside customers quickly, in real time, and most importantly, in their own language. With your rules programmed into the configurator, repeat work in some cases is almost completely wiped out and are shown to reduce lead times by up to 90%. Again, human error is minimized, business level practices and standards are followed, and these systems provide a platform for capturing the knowledge of your internal experts in case of the widely known, if anyone wins the lottery or retires or moves on or anything like that, your IP and data from that side is captured. Business benefits can lead on from the front end benefits as well. Automating design tasks leads to quicker sign-off. Less hours are spent on the design stage. You can redeploy this spare time on aspects of the business, other aspects, catching up on other projects maybe that have fallen behind, accommodating more business, or maybe even focusing on development and optimizing existing product lines. Image is everything at the end of the day, and companies who spend less time on complex designs can deliver quicker returns on GAs for bid proposals or quotes. You could then deliver that end product to the customer with shorter lead times, perhaps, if it's successfully won. Product validation at the front end reduces errors during manufacture and risk, enabling you to easily maintain compliance with standards agencies. Getting tongue-tied. On-site warranty jobs can potentially be reduced if there's less of a chance of a customized component failure because your design team has already conformed to your pre-programmed tolerances. All of this is aided by a standardized set of processes that's facilitated in iLogic. Companies are already doing this and are doing it well. Top performers here, so we've got top performers slide. These people are identified as manufacturing companies who have seen growth of 200 to 250% over the competition. As you can see from the unshaded areas there, these companies are much likely to use platform design, modular design and rules-based design approaches to optimize their configure to order and their engineer to order processes. Rule-based design had the largest gap there, by the way, of all the approaches. As you can see, 46% of top performers use rule-based design approach versus 14% of average performers. Just quickly, we've got also access to some leading industrial research organisations focusing on the business value investments in the tech. One of Tech Clarity's recent white papers focused on these top performers and how they used modern design processes and technologies to drive growth. They found that 84% of all respondents use 3D modelling, which is good. It's pretty much what everybody assumes now. The majority of people use 3D modelling. Around 50% were more likely to use design automation though in the workflow with the appropriate design tools, including things like simulation, the configurators that we're discussing, design automation, and factory layout tools as well. Top performers are likely using more advanced capabilities in the tools, for example to support platform and modular design, but this was evaluated as part of a separate study. These white papers are available, by the way. If you would like some bedtime reading, please let us know using the chat feature again on the right hand side. We can sort that out for you. Right, time for a case study of iLogic in action. James Walker Townsend, part of the James Walker Group, and they've been working with Quadra on their design processes. They design, manufacture and install a vast range of high-performance fluid sealing products. This particular project with iLogic, was based around their expansion joints. To give you an idea of scale, these things range from 200 mm square right through to 4 meter square ducts, and the solution that they offer ranges from the expansion joint provided on its own right up to a full system design with metalwork, supporting frames and so on. Inventor, Autodesk Inventor, is the group's design standard. They wanted to drive the design process from the start, right from customer engagement through the door, right through to manufacture with greater efficiency and a reduction in errors. They're quite complex parts, these, and the opportunity for error was quite high. They also wanted to integrate this information with their materials requirement planning, or MRP systems, so that they have a clear understanding of materials and labour resource at all times. This is something that iLogic can deliver. First objective was to automate the design of their standard variation. They had no real defined design department, but instead rather a product project engineers and managers. They had no recognised design department. Pain they had a bottleneck in proposals heading out to customers. They used a traditional method where sales teams gathered requirements that the engineering team then used to configure the products. Now these sales team guys weren't engineers, so they didn't often get all the information in. This was manually done in 2D, which was time consuming, depending on the product complexity and of course the amount of customization that the customer requires as well. There then became a bit of a trade-off between do we respond quickly or do we respond accurately? Product was often configured in 2D prints, and an estimate of BOM was produced for costing, but it was an estimate, it was inaccurate. In front of a customer, these 2D prints were often as well sometimes difficult to interpret, which results in a lot of wasted time with the salesperson trying to clarify that information. So design communication was a bit of an issue for them as well. Now though, with the configurator, the iLogic configurator, it ensures a much higher degree of accuracy when it comes to delivering the proposal. Also, a complete BOM, an accurate BOM, ensures that costings are accurate as well. Always good. Plus, it allows 3D modelling data to be used. 2D drawings can also be produced, of course, off it. For the technical people within that customer organisation, they can understand the 2D drawings, that's fine. And renderings and animations can be presented to people who aren't technically minded to generate their confidence that you fully understand their requirement, basically. Another quick issue they had, once the product was then configured, engineering needed to create materials necessary to complete the proposal. This was just 2D prints, as I said, and an inaccurate estimate of the BOM. If the bid was successful, often engineering needed to start from scratch and go back, remeasure everything and add that extra level of detail necessary for manufacturing. Again, using up valuable engineering time and extending the time it takes to deliver the product to that customer. Now though, when the bid is won, as you can see there, unless there is a very unique customer requirement, engineering doesn't require them to spend additional time detailing out the product. Data is readily available and leveraged into the MRP system. So what we're going to do now is we're going to look at Matt's prepared examples of iLogic in use. Again, please use the chat feature on the right hand side of the screen to pose any questions for us to use later on. Let's see how we get on.
I'm just going to create a very simple part, a plate basically. I'm going to name the dimensions as I create them. This makes them meaningful rather than D1, D2, D3, etc., which could get lost amongst lots of other dimensions. Now, standard inventor practice here would be edit the sketch, maybe modify the value, change it to something else, let the file rebuild, everybody's happy. Or we can access them via the parameters. Length, height, thickness, etc. They're all there. But I'm only actually interested in this case in those three. I don't care about D3. That's the taper angle of the extrusion. It's not a value I'm ever going to change, but it's cluttering up my parameters list. What I can do is very simply create a form within iLogic. We get a default blank form, and all we need to do is drag and drop. Drag the parameter onto the editor. As we can see, as we drag it on, the parameters are being added. We're not just limited to parameters, we can access iProperties, for example. So let's have the part number, maybe the description as well. This form is now building itself on the fly. It's keeping all the values that I'm interested in one place. As I modify those values now within this dialog box, just by moving from one text box to another, we can see the design updating on the fly in the background. The part number description, this comes from the iProperties. We're looking at the part number is blank at the moment, so is the description. But as we start typing values in there, once I apply that, the part number is pushed back to the iLogic form. The iLogic form reads the current values. The iLogic form can also write values as well. So this is an iLogic excuse me, sample. Click done. We have a look at the iProperties again. You can see that that's been populated. The iProperty dialog box does its job, and it does its job pretty well, but it is a little bit clicky. You've got to click around various tabs to fill in the bits of information that you require. What you require is not necessarily what I require or what the next person requires. So by being able to build a form within iLogic without any in-depth programming knowledge, we can put the values, the numbers, the properties that we need for the job we're doing in one place and make sure that everything's filled in. So long as you fill those 5 values in, everything else will take care of itself. It's a very simple example. There's no coding involved there. Well, we can take this to the next level. So the next file we'll look at is an oil tank. Okay, let's open up the next file. Now as a business we make containers. Liquid, water, oil, diesel, whatever it might be. We make these available in a range of sizes. The customer orders a 10 litre tank, a 15 litre tank, and we make to suit. I may not know the overall size required for a particular customer order, so I can set iLogic up to actually work those values out for me. Looking at the form that we've built here, we can input a desired volume, 13 litres in this case. If we look at the starting information, we're currently on about 10 litres. So we need to increase the size of the tank to accommodate the customer requirements. A couple of inputs, iterations, how many different tests are we going to do, and the interaction step value. Basically, every time we make a change, we increase the length by 10 mil, measure the volume. Is it within a particular tolerance, in this case 0.1 of a litre? If it is within that tolerance, we're good to go. So let's run this and see what happens. We can see that it starts increasing the size, the height of the tank and measuring the volume, and at this point now it tells us that this is the correct volume for the correct height, I should say, for a volume of at least 13 litres. So this will, within a 10 mil step, satisfy the customer order. This is a very simple test, a very simple exercise. If we look at the code, now the point of this webinar is not so much about the code itself, it's more to do with the application of that code. But if we look at the code that lives behind these forms, it just gives us a quick indication of the user interface. Now this is a couple of pages worth of code doing what eventually is a very simple job. But a lot of this code is reused. It's not necessarily written from scratch every time. We can access various elements. We can access the parameters. We can access the I properties. We've got access to document names. We can measure components. We can play around with iPads, what row, what cell, etc. We can play around with the constraints. Different elements of Inventor are all brought together within iLogic. The fuel tank itself is made up of an extrusion and a face draft and a number of other features. Each feature has a particular set of values associated to it. Everything's brought together within iLogic, and this then allows us to control those values. The form itself, as we showed on the previous example, it's just a case of dragging and dropping various elements from the editor, left-hand side, onto the editor main body. The form will build itself, it takes care of everything for us, and for what could be a very simple form, or actually quite a complicated form, we don't need any programming knowledge. All we need to know is that we're interested in values X, Y, and Z. This is a very simple example. It's a part that represents an assembly in the real world. iLogic will work with assemblies as well, so we'll have a look at that next. Now this next assembly is a piece of offshore equipment. It's a skid for a vessel. It's all been designed, everybody's happy. We have a walkway along the top now. Walkway requires guardrails, etc. You need some access as well, so we've designed the ladder. Now this is a generic ladder as far as we're concerned within our company. It's just, in this case, it's about a metre long. It's obviously not big enough, it needs to be longer. Rather than designing the ladder from scratch every time, we can use a standard ladder, and we can put a bit of an iLogic code in there. Yet again, we've got another form. Now at the moment the ladder is 1.2 metres, 1200. There are a number of rungs on there. We've increased the ladder length to 2000, for example. We can see that it increases in length, and because it's longer we have more rungs, but that's about it. It's still just an elongated ladder. If we increase the length again, we now get a change in the design. Obviously industry standards dictate that ladders can only be a certain height before some protection is required, in this case a cage. As we increase the height of the ladder, the iLogic code is doing some if-then. If this ladder is longer than a particular amount, then include or exclude additional features, in this case the cage. We can actually take this ladder even longer. Let's make it 6 metres long. We see there that the ladder's increased in length. The number of rungs have increased. The number of bands on the cage has also increased. Now there's no validation of the numbers within this particular iLogic model. It will make a ladder as long as I ask. But there's nothing to stop us putting validation in there. If it's longer than, then don't do it. In this case, if it's longer than the height of the platform, or if you request a height that's higher than the platform, then don't allow that particular change. Now we can look at something with a bit more coding involved, with a bit of validation on our next file. Okay, so the next file we're going to open up is an iLogic assembly of a wall. Some paneling on the wall. We can see it's made up of a row of green, let's call them tiles, and a couple of rows of blue tiles. Now the iLogic code within this file allows us to play around with some values, length, height and thickness, for example. So at the moment it's a 4-inch thickness. They're in excuse me, inches. This file's come from across the water basically. Now we change that to 6 inches, for example. We can see that the thickness of the wall changes and the components are being swapped out. So as well as modifying the components by increasing or decreasing a parameter within a particular file, we can swap out components as well. So we don't necessarily modify what's there, we change it for something different. This file's got some validation built in. So the wall height is currently 144. I set that to 100. It's more than happy. We can see that it's got a single row of green tiles and 2 rows of blue. That's fine. If I set it to 200 inches for its height, bit of validation. I violated the maximum size, which is currently set to 12 foot. Click OK. Rather than staying where it is, it will then set itself to that maximum value. The length of the wall, 200. We can see that that's then made up of 1, 2, 3, 4, 5 columns. If I set it to 300, it's now made up of 1, 2, 3, 4, 5, 6, 7 columns. Validation as well. If I ask for 400 inches wide, we've got a maximum of 30 feet, so it will then modify that value to be 360 inches or your 30 feet. Force 48-inch panel. At the moment, that's set to false, so each of these panels is the same height. It's just the height divided by 3 effectively. If I say true on that, now not a great deal happens at the moment because the value is divisible, so if we make it 120 instead, we can now see that we have a standard height 48-inch panel off the shelf, if you like, plus a shorter panel for filling in. Some rules and regulations. Do you want to use just standard components or do you want to use completely bespoke to suit a customer requirement? By being able to put in validation, if then, and this is what the whole of iLogic is built around, the if thens, do something. When I press this button, do something, and when I put value A, then you need to do B, C, D and E. The effort goes into the programming. Once you've programmed the logic, the benefit then, the payback on that investment, if you like, is the fact that the whole thing for this particular customer can then be designed with a form that's got 6 inputs. Spend the time and effort setting the form up, setting the parameters, building the logic, and get a payback on that investment by being able to design multiple iterations of the product as and when required. We're going to look at a reasonably big assembly. Vimtech is an Autodesk customer that's very kindly donated one of their data sets. So it's a real file. It's not something just built for a demonstration. Now it's a trailer. It's used in forestry and stuff. You've felled some trees. You've got to stack them up on the back of the trailer and take them away to be dealt with. Now they've got a form. Now the form, it's still an iLogic form, but it's had a little bit of a flourish put on it. We've got an image, we've got some sliders. It's a slightly different colour scheme. All things that you can play around to suit a company standard, if you like. You're not just forced to use the plain iLogic form out of the box. So in this particular case, we can play around with the length. So as I add a meter on, we can see that the design then updates. And once it's done its thing, there we go. We've added a meter into the length. The load height we can increase as well. You should see that the whole thing gets taller. And there we go. There we go. There's the fence. And the load width, we can play around with those values. Again, have a little bit of validation there. it tells us we've got to choose between 900 and 1200. So this time it doesn't reset itself to the maximum or the minimum, so we'll have to punch in the numbers ourselves. We can see that the design of the fence and the uprights change. Now the fence position, we can play around with that. We've got a slider. Each of these text boxes is linked to a parameter, which tends to be a value. Rather than just punching in the value, we can also have a slider with a given range. So in this case, we know that the fence position can be anywhere from 1 metre down to 500 mil from the end. Everything's built around parameters, so as one parameter changes, lots of other things change. Duty, we've got combo boxes, so we've got light and heavy. So set it to heavy duty, we'll see that the material thickness effectively is bulked up. Using an if-then statement, if duty is set to heavy, then insert components ABC. If duty is set to light, then remove components ABC and insert components XYZ. We've got off-road and road usage. At the moment we're using road tyres. We set that to off-road. You can see that they changed to something a little bit neater, a little bit better for dealing with the mud that you would find in forestry conditions. Jockey wheel, we can include, exclude. We can see within the browser that the jockey wheel at the moment is included. If I untick that, we can then see it's suppressed. So all iLogic is doing what we can do manually, but it does it a lot quicker and it adheres to the rules without us having to work them out ourselves on the fly. There's information being inserted into the form as well, just so you know. We've got the spacing, we've got the volume, so we can see how much lumber that we can actually hold as we increase the length. The volume increases as we increase the width, the height, etc. So we can play around with the design to get as near to a customer requirement as needed. Okay, so we've looked at parts and assemblies. So lastly we're going to finish off, we will eventually get to drawings, but just starting with a part. We've got a casting here. It's from an airport seating. It's one of the ribs, if you like, of the seating. Now we've got a form in there. Again, you can design the form yourself, you put the parameters in, dead easy. As we change the values, we see that the component updates. We can change the height, we can change the length, we can change the seat angle, so make it 100 degrees, for example. You can see that goes back a little bit. The tilt, you can play around with the tilt a little bit, so let's make that 0 degrees, so it tilts forward, 7 degrees, tilts it back. OD, ID depends on how many of these plates is going to be on the seating, the weight that this seating is going to have to handle. But it's all being driven by iLogic. Now we look at the parameters that we're dealing with. They are named parameters, as you'd expect. Now some of these are used, boss width, boss OD, ID, etc. One we've not looked at yet is rib width. That's not been included in the form. Now if you were doing this with Visual Basic, for example, now you can create a form using Visual Basic, and you can then use everything that's available to Visual Basic. You can create far more complicated, in-depth forms. Visual Basic, it could be paid for, VB, Visual Basic Studio. There is a free version, VB Express, that works just as good. If you understand programming, if you're of that nature, you may find programming in VB is more capable as far as the forms are concerned, because you can have lots of logic built into the form. The iLogic form itself is built text boxes, labels, combo boxes, etc. But it's a preset number of things. Excuse me. The benefit of iLogic though is if you need to change that form, it's very, very simple. You don't need to program it, you don't need to recompile it. All we need to do is edit the form, find the element that we've missed, drag and drop, we see it gets added to the list, and that's it, job done. It's instant, so we can make that 10 mil for example, and we can see that the file updates. It's that quick, it's that easy. Sometimes an external programming language, Visual Basic for example, might be beneficial because it's potentially capable of more things, but out of the box, the normal CAD user is able to use iLogic. You don't have to be a computer programmer. Now, once we've made changes to our design of our bracket, we can then open up the drawing, which obviously, as part of Inventor, it updates on the fly, it updates instantly. So we have a drawing there. Some of the dimensions have gone a little bit wacky, so let you know. Play around with them. You know, you fix the drawing, you do what you need to do. I don't like that one for now, so I'm just going to get rid. iLogic works just as well within the drawing as it does in the 3D environment. So I've got some rules here, for example, create DWF. If I just run that rule, we take a snapshot, we click yes, and pretty soon it will open itself up in Design Review. Now that's nothing you can't do manually. You can do a file save as. You can do an export to DWF, and it will create the DWF for you. But the benefit of running it via iLogic, there we go. The benefit of opening it via iLogic is it's instant. It's just a one click on that rule instead of going to the file menu and save as a number of steps. It's easy because you can run it either manually or run the code automatically. We've got event triggers. So on save, for example, we could select that particular rule, but every time we save the file, we also produce a DWF. We've got a create PDF option as well. Now this one will create the PDF, but it's not been set to automatically load the PDF in the background. I'm just flicking back to the original IPT. We've got a bit of code in there, CSV export. Now we'll run that rule. This will create a CSV file and listing out the parameters. So if you've got additional database, an ERP system for example, or just a spreadsheet that deals with part numbers, you can automate iLogic to link in with the spreadsheets. We've got code that will read and write Excel spreadsheets, for example. Now I'll just edit that rule. That code, again, it's not to be sniffed at. It's a bit of code that if you're a programmer you would understand, but if you never dealt with programming before, you would maybe find it a little bit too heavy. But one of the nice things about iLogic is what we call snippets. These are bits of predefined code that do a particular job. So if I just move down to the bottom, stick a couple of white lines in there. So read CSV file, for example. A bit of predefined code that just sets up that link between iLogic and an Excel spreadsheet, CSV, and we'll start reading it. What we're looking at with the CSV, so export parameters to CSV. It's all the code that we need to create a CSV of a list of parameters. We just need to fill in the parameter names there. They're all available in the top of the iLogic dialog box, so H length, V length, seat angle, etc. And this link is then made. Because this code is pre-written, it saves us so much typing. Export or publish DWF 3D. Everything we need to spit out a DWF. If you write your own code, and it's something that you reuse again and again, you can create your own custom snippet files. So if you're repeating the same work again and again, rather than writing from scratch, you can grab it as a snapshot and reuse that code. I think over time, as you use iLogic more and more, your library of snippets would increase. So initially the work might be a little bit slower because you have to write everything from scratch. But as you move along the process, that will speed up because you can reuse more and more of it.
Right, smashing stuff. Thanks very much to Matt for that, Matt Hutchinson there. So what can we do to help? Like all software, effectively you get the best out of it with the right foundations in place. This is where we come in at Quadra. Hopefully this webinar has raised awareness of what iLogic can do. If you find that it might have a part to play in the business, we want to help you to realise that potential. We have a wealth of expertise on the subject, as some of you out there already know, and we're ideally placed to support you in both iLogic and also Inventor programming. We've previously partnered with a number of clients, one of which you've seen before with JWT, to assist them with design automation challenges, and we'd like to invite you to get in touch with yours. Our team here provide staff development and technical support depending on the requirements assessed, which is done mainly through initial consultancy and looking at your objectives and where you think and want the iLogic to take you. We run a comprehensive 2-day introduction course as well. I think it's 2 days. Yes, it is. It's 2 days. It's a practice-intensive course, and it covers the iLogic interface and the essential skills needed to use it properly, from initial data capture right through to design workflow automation. You'll learn how to capture design intent, automate the design workflow, and look at various design scenarios in part assembly and drawing files. This is all part of the training. For more information about the course, please make a note of the website link quadrasol.co.uk/training.